Good day, students. How are you? Now continue the indefinite integration and consider the next integration method named the completing the square method. The completing the square method. This method has two types. The first type for arctangent, arctangent. It is in Azeri arctangent için tam kvadratın ayrılması usulü. In Russian метод выделения квадрата или полного квадрата, метод выделения полного квадрата для арктангенса. First consider more simplified example and consider example number 13. Example 13, the numeration of this example is according to to my textbook. Find the integral. Integral 42 dx over 49 x squared plus 36 equals. Here we must reduce the given integral to the integral of type integral of dt squared over t squared plus 1 equals arctangent t plus c. This integral is known from the indefinite integral table. Therefore, we must transform the 36 into unit. For this, take 36 out of the bracket in the denominator. Equals integral of 42 dx over 36 multiplied by 49 over 36 x squared plus 1 equals. Then we can take we can simplify 42 and 36 by 6. Here we will have 6, here 7, and then take 6 out of the integral symbol. 7 over 6 multiplied by integral of dx over 49 over 36 x squared plus 1. Then unite the expression under the common square. 7 over 6 multiplied by dx over 6 x squared plus 1. And then change 6x by new variable t. It is t. And write change. Let 6x is t. Then x is equal to 6/7 t. Then find dx. Dx is equal to 6/7 dt. And continue our integration. 7/6 multiplied by dx is 6/7 dt over t squared plus 1. Then further we can take 6/7 out of the integral symbol, and then 7/6 and 6/7 will be simplified. Then we have integral of dt over t squared plus 1, and according to the table integral, it is arctangent t plus c, arctangent t plus c, and then return to the given variable x, substitute 7/6x instead of t, and then we will have arctangent 7/6x plus c. It is our answer. Then consider the next example. Example 14. Find the integral. Integral of 3 dx over 2x squared minus 2x plus 5. Here we will also use the known table integral of dt over t squared plus 1 is equal to arctangent t plus c. For this we must complete the square in the denominator. Please complete the square. 2x squared minus 2x plus 5 is equal to it is comfortably for the completing the square if multiplied and divide this expression by 2. Then we have 1/2 multiplied by 4x squared minus 4x plus 10 equals. Then complete the square in the expression in the brackets. 1/2 multiplied by 4x squared minus 4x, and for obtaining the complete square, we must add and subtract unit at the same time. Plus 1 minus 1, and add the last term plus 10 equals. Then we have 1/2 multiplied by, it is 2x minus 1 squared. Already we completed the square plus 9 and you must know that the completing the square method for arctangent is used only for that for those integral in denominator of which of these integrals the discriminant is negative. Discriminant is negative. This code must be negative. Must be negative. Then substitute this expression instead of the denominator. Integral of 3 dx divided by 1 second multiplied by 2x minus 1 squared plus 9. Then 2 is transferred to the numerator, and then we will have 6 here, and then take 6 out of the integral symbol. 6 multiplied by dx over 2x minus 1 squared plus 9. Then we must change 9 by unit. For this take 9 out of the brackets in the denominator. 6 multiplied by integral of dx over 2x minus 1 squared over 9 plus 1. Then unite this expression, the first term of the denominator, under the common square. 6 multiplied by dx over 2x minus 1 over 3 squared plus 1. Then change the expression in the parentheses by new variable t. Write the next change, the following change. Change. Two x minus 1 over 3 is t. Then find x. X is 3t plus 1. X is equal to 3t plus 1 in half. And then find the dx. Dx is equal to t of 3t plus 1 in half. Then according to the differential formula, it is equal to the derivative of this expression multiplied by dt. 3t plus 1 over 2 prime dt. And derivative of this function is 3 seconds dt. Then use this change in the last integral. 6 multiplied by 3 seconds dt over t squared plus 1 equals then 1 second. Then it is equal to 9 multiplied by dt over t squared plus 1 equals. But here this integral is I'm sorry, here must write here also 9, because we took 9 out of the brackets in the denominator. Therefore we will have 6 over 9 I'm sorry, equals. Then we can take also 3 seconds out of the integral symbol. 6 nines multiplied by 3 seconds. Integral dt over t squared plus 1 equals. here we can simplify the expression. Then we will have integral dt over t squared plus 1. It is arctangent t plus c, and then return to the given substitute 2x minus 1 over 3 instead of t. Then we will have arctangent of 2x minus 1 over 3 plus c. It is our answer. Finally, remember the first type of the completing the square method. If the full integral is given, integral of kx plus L over ax squared plus bx plus c dx, and here the discriminant of the denominator of the quadratic expression is negative, then we can reduce such an integral to the integral of type dt over t squared plus 1, which is equal to arctangent t plus c. Then go to the second type of the completing the square for arcsine. Second type. The completing the square method. For arcsine. Here, the following integral is considered. Integral of kx plus L over square root of ax squared plus bx plus c dx, and if the discriminant of the square expression of the quadratic expression under root has the positive discriminant and the negative first coefficient, then we can use the completing the square method. Here discriminant must be positive and the first coefficient must be negative. And then in this case our integral, the given integral, will be reduced to the integral of type dt over square root of 1 minus t squared is equal to arcsine t plus c. First consider the simplified example. For example, example 15. This numeration is according to my textbook. Example 15. Find the integral. Integral of 3 dx over square root of 4 minus 9x squared. Here you see that here discriminant is positive because discriminant is it is first coefficient and it is constant term, and second coefficient is 0 squared minus 4 multiplied by minus 9 multiplied by 4. It is equal to 144 is positive, and the first coefficient is minus 9. The eldest coefficient or first coefficient minus 9, it is negative. This condition is satisfied, and therefore we can use this method. Then continue. Then we must transform 4 into union. For this, take 4 out of the brackets, out of the parentheses, in the root expression. Continue. Equals integral of 3dx over 9 multiplied by 1 minus 9x squared over 4 equals. Here we can take 4 out of the root expression. Then we will have integral of 3dx over 2 multiplied in square root of 1 minus 9x squared over 4. Then take 3 seconds out of the integral symbol and unite 9x squared over 4 under the common square. Then 3 seconds multiplied by integral of dx over 1 minus 3x in half squared equals 3x. We can change 3x in half by new variable t. Right, change 3x in half equals t. From here, x is equal to 2t thirds. Then find dx equals 2 thirds dt. Then use this change. 3 seconds multiplied by 2 thirds dt over square root of 1 minus t squared. Then we can simplify 3 seconds and 2 thirds. Therefore, we will have the integral dt over square root of 1 minus t squared. It is equal to, according to the table integrals, it is arcsine t plus c. Then it is equal to substitute 3x in half instead of t, arcsine 3x in half plus c. It is our answer. Then consider next example. It is our answer. Consider the next example number 173. Integral of dx over square root of x minus x squared. Here discriminant of the root expression is negative, because discriminant is equal to 1 squared minus 4 multiplied by minus 1, I'm sorry, 1 squared, yes, 1 squared and multiplied by 0, it is 1, is positive, and the first or the eldest coefficient is minus 1, is negative. Therefore we can apply the second type, the arcsine type of the completing the square method to this integral. First, complete the square in the root expression. Write root expression x minus x squared. For simplification, we can multiply it and first take the negative sign out of the brackets. Minus x squared minus x. Then for complete the square, multiply and divide this expression by 4. Minus 1 fourths multiplied by 4x squared minus 4x. Then add and subtract unit in this expression at the same time. Minus 1 fourth 4x squared minus 4x plus 1 and minus 1 at the same time. Already it is the complete square. Minus 1 fourth multiplied by 2x minus 1 squared minus 1. Then again introduce the negative sign into the brackets. 1 fourth equals 1 fourth, because I want reduce this expression to the expression of type 1 minus t squared. It is 1 minus 2x minus 1 squared. And now we can change to x minus 1 by new variable t. Let it is t. To x minus 1 is t. Equals change t. 2x minus 1 is t. Then x is t plus 1 in half. Then dx is d of t plus 1 in half. Then it is equal to t plus 1 in half prime multiplied by dt, and the derivative of this expression is 1 second. 1 second dt. Then use this change in the given integral. Integral dx is 1 second dt divided by square root of 1 fourth multiplied by 1 minus t squared. Equals here we can take 1 fourth out of the root symbol. 1 second dt over 1 second multiplied by square root of 1 minus t squared. Then simplify the integrand by 1 second. Then we have integral dt over square root of 1 minus t squared. It is already you know this formula. It is arcsine t plus c. Then return to the x. Substitute to x minus 1 instead of t in this formula. Arctangent, arcsine of 2x minus 1 plus c. It is our answer. Then I will give you your homework. Finally, please rewrite your homework. And today our lesson ended. Good luck. Goodbye, students.